Howdy there, fractal lovers. I'm Steve Sink, editor of the fractal software Mandelbulber's instruction manual and the main admin of the Facebook Mandelbulber site called Mandelbulbers, plural. Today we're going to talk about Netrendering with the fractal software Mandelbulber, which was invented and developed by lead programmer Christoph Marczak. There's several links down below to all of our tutorials, many done by me and Christoph and others in the fine community of Mandelbulber fractal lovers. First, let's talk briefly about what netrendering is and why you might want to do it. Then the two different kinds of netrendering, CPU for still images and GPU for animations, how it can but doesn't have to work with Windows Remote Desktop Connection, called RDC from here on out, setting up and using netrendering both for clients and the server, and then some tips, tricks, and cautions for you when using netrendering. So what is netrendering and why might you want to do it? Let's say you have a second PC that belongs to a family member or a spouse, or perhaps there's an extra work computer in the house, or an older PC or something that you've built or bought and want to add to an ever-growing family of PCs. For whatever reasons, you have multiple PCs, each with their own CPUs and graphics cards, and their own version of Windows, or perhaps even Mac OS or even Linux, which will all work with netrendering, although we're going to just stick with Windows for this video. All of these machines are just sitting there doing nothing when they could all be working together to make amazing fractal images. Some of the machines might be rack-based servers, some might be towers, some might be small desktops or large machines. We're going to be dealing with all flavors of Windows. The procedures are pretty much the same, to include Windows for servers as well. We're going to install a version of Mandelbulber onto each system and get them not only to talk to each other, but work together to make either a single fractal image with CPUs or use their graphics cards to make multiple frames of an animation. Netrendering allows you to use multiple machines, and each with perhaps multiple graphics cards, to all work together and render together as one big networked group. Servers and clients. There is one machine, usually the main computer that the user intends to work from, that is designated the server, and it has the settings for the animation or image to be rendered. It should have all the files that Mandelbulber will reference as inputs to create its own images, such as texture images, audio files, backgrounds, light maps, HDRIs, etc. The other machines that are connected to the network are called clients. They must each have the same version of Mandelbulber installed on them as the server has, but they don't have to have the settings or files to be rendered, which have to be pushed out to them. How netrendering works. The server will push out settings and all needed images, textures, and files to the clients, which render either several lines of a single common image with CPU rendering, or they do one frame a piece each with GPU rendering. When the lines or frame is rendered, the client sends it back to the server, who writes it all in whatever folder on whatever drive it wants the image or animation frames to be stored at. The clients don't actually write directly to the folder, so any folder on the drive connected to the host machine can be used to store frames, even if it's not network shared with the clients. The server keeps assigning new lines or frames to the client as they get rendered until the entire image or range of frames is complete. Each time you hit render in animation, the server checks the folder for the range of frames specified, and then will assign out all frames that are missing. So if you delete out any number of frames and then re-render, Mandelbulber will automatically find which frames are missing and render out all the rest. Still frames with CPUs versus multiple frame animations with GPU video cards. Networking for single images will only work with CPU rendering. It does not work for GPU OpenCL rendering on different machines. Networking will only work on the same image if each machine has OpenCL turned off in the OpenCL settings tab, and if each machine is using its CPU to render together. Using OpenCL on our graphics cards, we can work on the same image, but only if all the cards are installed on the same machine. And they can be a mix of different cards on one machine as long as they are all NVIDIA or all AMD. But that's not net rendering, that's multi-card rendering on one machine, which can be combined with net rendering, i.e. multiple machines each with multiple cards installed on each machine. Multi-card rendering is as simple as just plugging in several powered cards to one motherboard and then pointing Mandelbulber to each card in the OpenCL settings tab. I have a 5-card render beast machine that uses mining risers to stand off 5 separate cards for rendering all together as if they were one big card, but that's outside the scope of this video. We're going to focus on mainly GPU net rendering because that's almost all of the net rendering that I've ever done, as I do very little CPU fractals in the first place. CPU fractals are much slower than GPU fractals by a factor of almost 100 to 1 in some cases. So how can net rendering work with Windows remote desktop connection, although it doesn't have to? So the question is, how are we going to connect all of these different machines together that are all using the same version of Mandelbulber? We won't get into the intricacies of home or business internet networks, but many of us have a central internet router that has multiple PCs connected to it, whether by Wi-Fi or LAN cable. I have computers connected using both. Ultimately, it's the server and all clients that are connected somehow to the same internet network. And since all these connected devices are all using Windows, we can use Windows Remote Desktop Connection, RDC, into each machine from our host machine and control the client machines as if we had connected a monitor, keyboard, and mouse to it. We basically open up a window into that machine that would show us everything that it would show us if we were directly connected actually to the machine via a monitor, keyboard, and mouse. Only this means that all of our clients merely need a LAN cable or a Wi-Fi connection, and they do not need each their own separate monitor, keyboards, and mouses. We will be using RDC to control and set up each of our machines. After each machine is set up and Mandelbulber is running and connected to net rendering, we can close out the RDC and reconnect as needed or not. Mandelbulber and net rendering will run just fine in the background on its own without RDC. And we're just using it to set up our computers. We could physically go to each computer and set it up the traditional way using a connected monitor and peripheral mouse and keyboards. The first thing we need to know is the name of the machine that we want to RDC into, which is assigned by Windows, and there's a number of ways to do that. We're going to need that same Windows machine name for net rendering as well. Or it could be an IP address, but the name is easier and it doesn't change as IP addresses sometimes can. Here's a quick way to find your computer name on Windows 11. Simply go to the Start menu, hit your Settings, and immediately there is your computer name right there if your default is home. If you go to System, you'll see the same thing. My computer name is Ryzen 7950X. It even has the name of my motherboard attached to it. There are a number of great YouTube video posts that will get you going on Windows remote desktop connection. And I have a link posted in the description to a great one by Carson Cameron Clark that'll help get you set up. He shows you how to find your computer name, although I just did as well. Also how to get RDC going. Do that and come back here and then I'll show you some more. And we'll set up net rendering. Setting up and using net rendering. First, setting up the client or clients. So after RDC is installed and running, go ahead and open up a window to your client, or we can set it up manually without RDC. The process is still the same for either one. Install the same version of Mandelbulber that the server is using if it's not already installed. Use my Mandelbulber quick start guide tutorial if you need to, also linked down below, to get the machine set up and pointed to the GPU cards you want to use on each client. Set up the Windows timeout registry change for your video cards so that your client won't time out for taking too long on a render as well. That's explained in my Mandelbulber quick start guide. Once we're done with all that, we're going to open up that instance of Mandelbulber using Windows remote desktop connection. I'm going to close out my existing connection and open up one. I have one pinned to my bar here. The name of this computer is Ryzen 5800X. Yes, I name all my computers after the CPU that they are seated with. We're going to connect, and you'll see that I already have Mandelbulber installed, same version, waiting on this host machine, and antivirus protection. Here's my desktop. So this is the host version of Mandelbulber, the client version that I'm looking at through Windows remote desktop connection. Okay, so what we're going to do is we're going to go to the rendering engine tab in the lower left side of Mandelbulber, scroll to the bottom of the pane, see rendering engine right here. This is already at the bottom of the pane. We'll see this pane here is the net render pane. This mode is currently client. It switches between the server and the client. As it explains in the tool pop-up here, the server is the main application in the network. It controls the rendering process, sends data to all the clients, and collects data from them. Server compiles parts of images received from the clients and finally displays the whole image. It also renders images itself. The client receives jobs from the server. It renders only the parts of the image which the server asked for. It displays only partial images. To start rendering process on all computers, you need to press render button on server. And that's the render animation button right there on our server. So as this is a client, we will set it to client. The next thing to set is the remote server address, which we could do the IP address. And you'll see the pop-up says IP address or name of the computer where Mandelbulber is launched in server mode. Ryzen 7950X was the name of my computer, which we got just a few seconds ago via that process. The next parameter we have that we could change is the remote server port, that by default, that is always set on port 5555. I've changed it before just to play with it, and there's really no need to. Just leave it on 5555. There's perhaps ports that would be bad, but there won't be anything wrong with you leaving it like it is. And then simply, the next thing we do is just simply connect to server. And once we connect to server, we'll have a status down below here that'll say reconnecting, and it's looking for the server at port 5555 called Ryzen 7950X. Okay, the client is completely set up now. It is ready to go. Assuming that we set up the Mandelbulber to render fractals as normally, all we needed to do was come over to here to this rendering engine pane, make sure that the name, and then this will all stay, by the way, when we close out Mandelbulber, it will remember all of these settings from one instance to the next, which is extremely handy. So we will leave these settings the same, and it will just sit here waiting forever for the server to connect. Next, we will connect here on my main host computer. Then see I'm out of Windows Remote Desktop Connection. That's it running down here in the corner. I'm out of it, and we'll go to the same rendering pane, scroll down this time because there's obviously a little difference between my font sizes from one computer to the next. We see that this mode is set to server. We want to leave it on server because it's already server, and we don't have to tell it the name of the network because it's this computer's name by default. Here's another pop-up that we just read. Server configuration. There's nothing to change except this port number, which we want to leave at 5555. We could change it to something else, but we just need to make sure that all the clients have the same port number, of course. Now, as soon as we hit launch server and watch for clients, it will launch. Now, the very first time we do this, a Windows pop-up will say, do you want to allow network connections? You want to say yes. If you say no, there's almost no way to undo it short of uninstalling Mandelbulber and reinstalling it and hoping this pop-up happens again, or that you install a new version of Windows later on in the future. So when you hit this for the first time, click the yes when Windows asks you if you want to accept Windows connections. It won't do it for me now because I've done it in the past. I can't force it to do it. You would think it'd be just a simple matter of going into Windows Firewall and adding Mandelbulber as an app, but no, that doesn't work. I haven't never been able to figure it out. I've had to uninstall Mandelbulber. So just, I'm going to repeat this in the tips, tricks and cautions at the end, but be careful. Launch server. And immediately we see Ryzen 5880X was found. There's the IP address. It even tells me how many CPUs that computer is running. It shows me the status ready is 0. It shows me how many items have been done. Items in this case would be frames, since we're going to be doing GPU animations with it. And then this right here allows me to dump this particular client if I want to dump the client. Of course, stop server will also stop the server. And meanwhile, I'm going to go back over to here to my client, which you see now the status has changed to ready and green. And we see the connected server's name, Ryzen 7950X. This server is all ready to go. Now, one more further tip, minimize this screen, including if this screen here is up as well, minimize it. And then do yourself a favor, on your keyboard, hit Control, Shift, and Escape, and you'll prompt on this Ryzen 5880X, the task manager to pop up. That'll tell you I actually have two GPUs installed on here, a 3080 Ti and a 2070, that are both working together on one machine. So this will let me know when I start rendering without having to look at the app itself. The reason we don't want to look at the app itself is because it does weird things when we look at it through remote desktop connection when it is connected as a client. It's a known bug. I believe it's a QuickTime error. Christoph has been trying to squash it. We haven't been able to figure it out. So when you're doing net rendering, don't mess with the clients once they are engaged with the network and actively doing things. You can mess with the server all you want. Don't mess with the clients. What happens when you mess with the clients? Frames will return weird. They'll have some effects turned off, and then you'll have the worst error that's called the Mandelbulb error. It will replace whatever formula it's using with a default Mandelbulb formula. The camera settings and everything will be the same otherwise, but it'll be a completely different scene. And it will only be those frames from that server that from that client that you were messing with. And so that means when you look at the total folder at the end, there'll be every 6th or 7th frame, a frame here, 12 frames there, 20 frames there, will all be messed up. The only way to fix it is to go manually delete out all those bad frames and hit re-render, and Mandelbulber will automatically find the frames that are missing and re-render them. All right. Tips, tricks, and caution on that one. Don't mess with the clients once they're connected to the server. Okay, now we're going to go to the 5-card render beast real quick, and we'll see we have 5 video cards connected to this computer, 4 2070s and a 1080 Ti. And just as the other just as the other client, we're going to go to the rendering engine. We'll see that the name and the port are already set up. We'll connect the server. We'll see it goes immediately to green. Minimize this. Make sure the other one is also connect to server. There we go. We should have 2 clients now looking for a server. And here we go. There's my 2 different computers, both of them with 16 CPUs. And were I just to hit render animation and actually had an animation going here, the 2 of these connected clients would start rendering. And that is why I might possibly want to have cards set up with multiple card. I might want to have instances of Mandelbulber set up with multiple cards. Go here to the OpenCL GPU settings, and you'll see that I have all 5 cards selected. I might want to select 3 cards on one instance, open up another instance of Mandelbulber, select the other 2. In this case, I'm going to use all 5. Okay, and that is 2 separate clients connected to our server. So for a CPU still image, we're going to have no OpenCL here on OpenCL mode. Each one of our clients is also going to have no OpenCL mode connected to our network. Our second client also no OpenCL mode, but connected to the network. And then back here at the main server, when I want to do a single image and I want to pull in these other two, once everybody's in no OpenCL mode, all I have to do is hit render, and my main server will start doing some lines of the image, but also each one of the clients will start doing some lines for image. The clients will send the lines back here to the server, and slowly we'll start to build in the scene with lines rendered from our clients. If we go back to our clients and look and see what they're doing, we'll see that they're making individual lines of this image. That section, this other client, is doing a completely different section. And here back at the main server, I'm doing some lines myself on this computer, plus all of the lines from the clients, which are all blending together to gradually make this scene. And through the magic of video, I will speed up the remaining 2 minutes and 24 seconds of this process. And through the magic of editing, we slow down as we come in through the last 23 seconds of the video. You'll see that it's putting the final lines into the image. We see that my one client has done 92 lines. This other client with the more modern chip has done 161 lines, which actually is as I would expect, even though they're both 16 CPUs. There we go. The first one returned 95 lines, the second returned 164, then all the other lines were done by the server. And then here is the final image, all done through the magic of Mandelbulber Netrendering. Now if we want to start our animation, we make sure that our OpenCL mode is on full. We're going to have to go to our clients and restart Mandelbulber at each one of them. If we try to reuse Mandelbulber after it was set in a CPU mode, it will not work right for us. So we have to go to full here now, and then we can go to Rendering Engine Connect, and then we'll minimize this. And we're going to do the same thing under other client. We're going to go to Mandelbulber, open it up, change it from OpenCL mode of none to full. No OpenCL mode here. We're going to go to full. One more time, full. Then we go to Rendering Engine, connect to server. We're all set up and ready to go now for animations. Now we're going to be using our graphics card, and it's going to go a lot quicker. I have just a simple quick animation here. The scene we did previously, which with my graphics card takes all of that long. Which is why we use graphic cards instead of CPUs for Mandelbulber when we can. And then here's my second scene, and I'm just going to animate between the two. My clients are all connected and ready to go. And I'm just going to hit render animation this time. I have a folder set up. Let me delete out anything in that folder real quick. All right, and we're going to go ahead and hit render, and now my server is going to be doing some rendering, but also each one of the clients. Server starting on frame 40, and it's going to assign 20 frames each to these two clients to render out. They're going to take a little bit to initialize. The first client has already returned 1 frame, and it looks like we've done a couple of frames here. Second frame's been returned by that first server. This computer here typically takes a long time to initialize. There it goes. It's now returned frames. So if I go here quickly to show animation, I see I've done 9 frames, and there's the 10th frame and 11th frame. You see that this computer, and then there's a 12th frame. So you see that the frames are being written by all the clients, and the animation is proceeding forward. And so this would then animate all 200 slides of this, or actually in this case 150, excuse me. And through the magic of editing, I'll go ahead and let this edit out the remaining 8 minutes to do 150 total frames.
Crazy thing! Hey! Help!
Now, as we come into the end of this animation, the first server has just finished its frames while the clients still have a few to render. We can check by hitting show animation 135 that actually there's about 12, 13 more frames to be done by the other two, by the server and the client. If for whatever reason we're in a hurry, we can always stop the servers and render out the rest of the missing frames using the main server, if in fact our server is the faster renderer, which in my case it very much is. But I'll give a few more seconds, and the magic of editing will go pink right to the end. And we see both servers, both clients have stopped out. One did 57, one did 48. They've done a total of 151 frames for this animation, with the starting frame being 0, and then I did 150 after that. Sorry, go back to frame animation real quick. We can just scroll through, and you see we did a quick animation, in and out, in and out. At 30 frames per second, roughly would look something like that. I didn't animate any of the fractals. Ideally, this wheel would have been moving and things would have been morphing and whatnot. But that was net rendering for animations. We hit stop server because we were all done, and we've done both CPU and GPU rendering. Okay, another tip, trick, or caution. You can set up multiple instances of Mandelbulber on each of the networked machines. You might want to do this to assign different cards to multiple instances of Mandelbulber. For large texture files, it can really slow down multi-card machines because the files get sent to each of the cards sequentially instead of all cards at once. So on my 5-card RenderBeast machine, I run 2 instances of Mandelbulber and thus have 2 different clients on that one machine, one with 2 cards and then one with 3, so the load time is cut down and they load faster. The server actually sees 2 clients with the same name but treats them as if they're different machines. As we mentioned before, you can delete out bad frames and change some settings and then re-render them, and Mandelbulber will only do the frames that you deleted out. We talked about selecting yes when you accept network connections the first time. If you don't, oh, it's really bad. Also said don't rummage through the client's windows when they're net rendering because you can mess up frames. One more thing, you can connect additional clients to the server while the animation is rendering, but they will not start rendering until you stop the server on the main machine and then restart the animation render. They will just sit there dumb and connected, but not rendering until you stop and then restart. So if you kick off a server and then a client and then restart it, it will join the network, but sit there and it won't render until you stop all animations and restart it. Okay. That's not possibly everything about net rendering, but it's the big stuff. And Christoph Marczak, the inventor and lead programmer of Mandelbulber, can no doubt add to this and perhaps answer any questions that you might have. I will get to every one of the comments, I promise you. I'm pretty good about that, and I especially recommend coming to Facebook Mandelbulbers with an S and talking to us there and participating in our weekly fractal challenges. And you can also post your own fractal art made with Mandelbulber and other fractal software. And also look at the amazing fractal pieces of your fellow fractal lovers. Okay, that is all for net rendering with Mandelbulber. Good luck and happy or angry fractals. Cheers.